Okay, Bismillahirrahmanirrahim. We start our lecture today with a number of theory. Number theory basically is a branch of pure mathematics devoted primarily to study of the integers and integers valued function. Okay, basically number of theory also known as a branch of mathematics that concerning with the properties of the positive integer, or sometimes it devoted or appropriate with the higher arithmetic. This one sometimes called as a higher arithmetic. It is more concerning of the number theoretic questions. Okay. Okay. Sometimes called higher mathematics. Higher arithmetic. Okay. This one is about integers and also about the properties. Okay, number theory about the integer and their properties, and then we will start the basic principle of divisibility, and then we take into the modular arithmetic, or sometimes we call it as a mode. And then we have a GCD, greatest common divisors, and then we have least common multiples, LCM. And then we take a look at some relevant algorithm, basically appropriate about the numbers of theory. Okay, first we take a look from the primes and great common divisor, GCD. Okay, for the division, if you can see, division is quite common. If you have A and B, we call it as integers, numbers. With A is not equal to 0, we can say that A divided by B if there is integer C. So B is equal to AC lah. Okay, for example, if you have the AB 3 divided by 12, 12 uh, is equal to 3 multiplied by 4. It is integers. Okay, then it has a reminder of 0. And then when divide B, we can say it is a factor or divisor of B, and B is a multiple of A lah. It is divided. Okay, so we can say that integer is C, and the notation is A divided by B lah. Okay, A divided by B, and the reminder is the balance. The balance is dividend, dividend. Okay, dividend. We write A multiplied by B when it does not divide by B. Lah. Okay, for example, okay, 3 is divided, can be divided by 27 because the remainder is 0. Okay, and then for example, 5, 27 is not it's not divide it's not can be divided by 27 because it has a remainder of 2 lah. Okay, for this one. Okay. Do you have any questions so far? Is it okay? Is it okay? No, 3 palang bar 27 means that it can be divided by 27 lah. Okay, it is the can be divided. Means that A can be divided by B by the remainder of 0. For example, if you have, let's say, okay, okay, A, okay, 3 divided by 27, okay, put like this, the remainder is 0 lah. Okay, boleh siapa yang tanya tadi? Uh, this one is a division algorithm lah. Okay, division of algorithm. Basically, when you have a reminder, is not can it need not be said that it can be divided by b lah. Okay, this one is a factor and then is a divisor lah. Okay, for example, we have three bar and then 25 and we have dividend. Okay, dividend is 25 is you put in the dividend. We have a reminder. Okay, and then you can see this one is the integers. 3 divided by 9 is reminder is 0. You can say as 27 is the total of 3 multiplied by 9. And then, okay, this one is not integer. 3, uh, you have a reminder 1. And then the complete total of factor. Okay, factor and divisor. Factor is 25. And then when you have the total is 3 multiplied by 8.3333. It is not the integer lah. It must be integers lah, for both factor and also for the dividend. Okay. And then we look into the divisibility theorem. For integers, we have a, b, and c. It is true that if a uh, bar b and c bar c, then a bar b plus c, it is the total up of a lah. Okay, for example, we have 3, 6 and 3, 9. So 3, 15. We have 3 and 15. If a bar b, then a b c is for all integer c's. For example, we have 5, 10. So 5 is 20. 2 multiplied by 10. Okay. And then 5, 30 is 3 multiplied by 10. And 44 multiplied by 10 and so on. Okay. This one is divisibility theorem. Okay. If we have 8, 4 and 8. Okay, and then 8, 24. Tak keluar eh. Ya eh. So we can see that 4 is also can be divided for the uh, divisor. Okay, is the dividend. Okay, 4 can be divided also by 24. Okay, the algorithm is simple. Let A be the integer and D is divisor is a positive integers. Then there are unique integers Q and R, with 0 is less than R, less than D, such that A is equal to DQ, D multiplied by Q plus R. Okay, we have coordinate. A is divided. Okay, and D is a divisor. We have divisor, coordinate. Okay, and dividend, and then we have a reminder. Okay, and then we have okay, D, A, Q, and R. Okay, and then 0 is less than R, reminder, less than D, divisor. And R must be a positive. Okay, this one is the algorithm. Okay, later this we look into this. Okay, for example, if you look for the continent and reminder. Okay, I give you an example. Okay, example we have A is 21. Example A is 21. B is 2. Okay, if you see here is 21. We have uh, 21 2 multiplied by 10, and we have remainder 1. Okay, and then we have Q for coordinate and R for the remainder lah. Okay, coordinate, we have coordinate here Q, and then we have a remainder R. Okay, for this case, this one is a reminder. This one is coordinate. Quotient. Okay. TNT. TIENT. Okay, Famarita, is it okay? Is it okay for you? Dini okay ke? Dini? Boleh ya? Okay, okay, this one is we have learned a divisor, dividend, quotient, and the remainder lah. Okay, another example, what happen when we divide negative 11 by 3, eh? Note that the remainder cannot be negative. This one is cannot be negative lah. And then if negative 11 is the dividend, 3 is divisor, negative 4 is called quotient, and 1 is called remainder. Example, uh, find 17 mode 5 and find negative 133 mode by 7 lah. Okay, for example number 1, 0 is less than or equal to R. Okay, reminder, less than D, divisor. Okay, when you divide, okay, 11 divided by 3, okay, you can have the quotient, quotient 3, quotient 3, and then you have reminder 2 lah, is less than 3 lah. Okay, and then 11, 3 multiplied by 3 is plus 2 lah. We do like this lah. Okay, and then number two, when you divide negative 11 divided by 3, is you have quotient 1 is less than 3 also. And then divisor 3, and then we have quotient negative 4, and then we have plus R, also true lah. Okay, because number 2 R cannot be negative. Okay, R, the remainder cannot be negative. Okay, it is okay lah. Okay. The remainder is not negative. Okay, you have 0 less than or equal to remainder less than divisor lah. Okay, and then the division algorithm. Example, when we divide 17 by 5, we have 17, and we have 5.3 plus 2. And then we can also categorize 70 is dividend. Okay, 5 is the divisor, 3 is called quotient, and 2 is called the remainder. Okay, we have 5 here. Okay, okay, this one reminder. Okay, 3 is quotient Q, 5 is divisor D, and 17 is D, dividend. Eh? D is dividend, whatever integers that divided by some values. Okay, we have quotient, 2, reminder. Reminder is 2. Okay. And then we have modular arithmetics. This if A is integers and M positive integers, A mod B is a reminder when A is divided by M lah. Okay, and then if A is equal to QM plus R and 0 is less than or equal to reminder is less than M lah. Okay, then A mod M is equal to R. Okay, for example, find 17 divided mod by 5, and then we have 5 divided mod 17. Okay, and then we have negative 133 mod by 9, 5 mod by 17. This one is just for the example. Okay, we have 4 divided mod 15 is equal to 4. Okay. And then we have 15 mod by 4 is 3, 15 mod by 3 is 0. Okay, we have 15. Uh, okay, this one is the reminder. Okay, reminder, and then we have reminder 4 is less than 15. Okay, and then we have 15 mod 3, 15 mod 4, 15 mod 4. Okay, we have negative, we have 3 is less than 4. And then finally we have uh, 3 divided mod 3 is 0. Okay. Okay, and then we have negative 133 mod by 9. Okay, we have 9. The, this one is negative, negative 133 mod 9. And this one is divided. Okay, and then we have remainder is 2. Okay, we have 9 multiplied by negative 4 is negative 36. 9 multiplied by 5 is negative 45 lah. Okay, and then the remainder is 2 lah. Okay, do you have any questions so far? Is it okay for the mode? Is it okay? Megat okay ke Megat? Modular modular. Okay, we have M. Okay, modular M is a divisor and then implies the remainder R. Okay, in mathematics, modular arithmetic is system of arithmetic for integers where numbers wrap around when reaching a certain values. We call it as a modulus. Okay. Okay. If you don't understand, I can give you another example. Okay, another example, simple example for modular. We have 8 mod by 4 is equal to. So, Zwana, what is the answer? 8 mod by 4. And 0, y 0, y 0. Tak ada answer. Okay, for the example, mod by 9, we have 4, 8. Okay, the answer is 0. It's a reminder. Okay, for this one, we can start with clock with the number 0, 1, 2, 3. This one is example. Okay, we have clock here. Then we have 0, 1, 2, 3. Then we have 8. Eh, sorry. 8 mod 4 lah. Okay, we start at 0 and go through 8 numbers in clockwise. Sequence 0, 1, 2, 3, 0, 1, 2, 3, 0. Okay, so we end up at 0. So 8 mod 4 is equal to 0. Okay, we start from here 0, 1, 2, 3, 4. Sequence, we start at 0, go to 8, 1, 2, 3, 0, 1, 2, 3, 0. Okay, from here and then we start again 0, 1, 2, 3, 0, 1, 2, 3, and 0 again. Okay, another example. Okay, negative 5 mod 3 is equal to. Atika, berapa Atika? Okay, this one. Okay, we have negative 5. Okay, by 3. Okay, and then we have 1. 3. Mod 3 is equal to 1. Negative 5 mod 3 is equal to 1. Okay, 3, 2, 6, 1 lah. Okay. Okay, then we have modular arithmetic. Let this one another example. Let a be the integers and m be the positive integers. We denote by m mod m. The remainder is when a is divided by m. For example, we have a 9 mod 4 is equal to 1. 9 mod 3 is equal to 0. 9 mod 10 is equal to 9. Okay. Okay, and then negative 13 mod by 4 is equal to 3 lah. Okay, please do this exercise. Find the 127 mod by 3 and negative 127 mod by 3. Okay, this one upload to Padlet for the exercise. Okay, so I think we need to rest. Okay, we can we rest now?